All right, so first off, on behalf of all the other organizers, thank you all so much for being here. I know for some of you it's an easier time than others, so thank you for the ones that are making time in their evenings. We also want to give a special thanks to the people at the KITP for making this conference happen. A lot of organization went on behind the scenes from them, and hopefully it'll work out really well. We want to first set some ground rules for this conference. So we're not physically at the KITP, but we thought their code of conduct laid out a good framework. So I'll put that in the chat. There are a few things on there, but most importantly, sort of common sense. Just treat each other with respect and behave professionally. Obviously, we're mostly all at home in our houses. But we need to keep in mind that we're sharing a space with 200 other people, or however many people are here, a bunch of other people, 120 other people. So please act accordingly. And if you keep your camera on, which is fine to do, remember that 200 other people can see you. So don't do anything you wouldn't do out in public. And last order of business, there is a Slack workspace for further discussion that you can use during the coffee breaks. I'll post that here. Yeah, and I think that's it for logistics. So without further ado, let's get started. Our first talk is by Nicola Gentile Fusillo, and it's about white dwarfs in Gaia. And it's 12 minutes, followed by 8 minutes of questions. And I think we can just get started.
Okay.
Do we have to? Good, and you're unmuted? Yeah, perfect.
Yes. Can you see my page, my screen?
Yes.
And
yes,
and the cursor as well, hopefully. Okay. So before I spend the next few minutes powering you through the work I've been putting into the goal of creating a new catalog of white dwarfs based on Gaia eDR3, I'd like to thank the organizers for giving me the opportunity to present my work here and the rare opportunity to be the one opening this very nice initiative. And I also want to extend my thanks to the many people at Warwick who have helped me in the work I'm about to present. Before I jump straight into eDR3, though, I'd like to give you a quick reminder of what the situation was in terms of our samples of non-white dwarfs just a few years back. Before 2018, so before Gaia Data Release 2 came out, we knew about 40,000 white dwarfs. Most of these came from the Sloan Digital Sky Survey, and the distribution of these objects is what I'm showing here in the top left, a very non-uniform sample. Then in 2018, Gaia Data Release 2 came out with its parallax measurements, which enabled us to identify roughly 260,000 white dwarfs, which is the sample underneath, a much more uniform and complete sample. However, even Data Release 2 was not without its limitations, and in terms of the white dwarf catalog at the time, that could be considered complete only out to 70 parsec, roughly. But even in our immediate neighborhood, within 20 parsec around the sun, there were a few very well-known white dwarfs which simply did not have reliable Gaia PET measurements. Also, for the oldest and therefore coolest, faintest, and reddest white dwarfs, well, these objects were still quite challenging to identify because of contamination from other spurious red sources in Gaia. And then, a few months ago, the early Data Release 3 came out. And this time around, we got 34 months of data to play with compared to the 22 months we had for Data Release 2. This translates in more precise parallaxes, more precise proper motions for millions of more stars. eDR3, however, has to be considered a completely from the ground up reanalysis of the Gaia data. And actually, in the Data Release publication, they warn users against direct comparing Data Release 2 measurements with Data Release 3 measurements. So in our quest to construct a catalog of white dwarfs based on eDR3, we decided to start from scratch. And for me, starting from the beginning, meaning starting from 30,000 spectroscopically confirmed white dwarfs from the Sloan Digital Sky Survey. So the first step was to create an HR diagram, like the one you see here on the left, where the white dwarfs from Sloan are these blue dots, and The gray dots here are just a random sample of about 2 million Gaia objects. We use this plot to just initially determine where the white dwarfs are and identify a cut, this simple red line, to isolate this area. We also decided to include only objects with a parallax over error greater than 1, simply because anything with values lower than 1 does not have a defined position in the HR diagram. These are very broad selections and included well over 14 million objects. And of course, the vast majority of these are not white dwarfs, and they're not even good. Some of you may already be familiar with eDR3 with some extent, and in some of the publications associated with the data release may have seen quality cuts used to clean samples that were recommended in a couple of places, in particular these two, with Rue and this other long-named parameter. If we just apply these cuts, however, to our 14 million objects, we still end up with over 85% of all of these objects, while at the same time, we already reject 10% of all of the Sloan spectroscopically identified white dwarfs brighter than G magnitude 20. Therefore, these cuts that have been quoted several times are simply not good enough for us. Fortunately, Gaia eDR3 has a lot of flags and a lot of parameters which we could use in our attempt to remove the vast majority of objects while preserving virtually all of the white dwarfs. We ended up using a complex combination of all of the ones I'm listing here, which I'm not going to go into the details, but there are at least 4 high impact parameters, which even those among you that are familiar with eDR3 may have not come across, and I would like to mention. The first one is Astrometric sigma 5D max. Roughly speaking, this is a measurement of the robustness of the 5-parameter solution for Gaia sources, and a high value in this flag indicates that something has gone wrong. Then we have proper motion divided by proper motion error. This is not something provided in the Gaia archive and something you have to calculate yourself, but because proper motions in eDR3 improved so much, this becomes actually a very good indicator of the reliability of the astrometric solution for a Gaia source. A straight cut in this parameter, though, will bias you against objects with low proper motions, but it's relatively safe to use for white dwarfs. Then we have corrected BPRP excess factor. This is a measurement of the internal consistency of the... Hello? A measurement of the internal consistency of the 3 Gaia photometric band, which has been then adjusted for its intrinsic dependency on color. Again, this is not something that is provided in the Gaia archive. It is described in one of the papers, but more importantly, there is a GitHub repository where you can download a little Python code to calculate this. And then there is something I called density, which is some measurement of crowding. And I can visualize for you why this is important. These are, again, a selection of random Gaia sources plotted in galactic coordinates. And if we just use array and deck, that's all we get. Not much information here. But if we then bin the sky and count the objects in each bin, a lot of structure emerges. And this is much closer to what Gaia actually sees. And as it turns out, Gaia still struggles in those areas of the plane and the Magellanic Cloud, which are very crowded. So it turns out that we still need to apply stricter selection criteria in these areas of the sky. So after a painful process of trial and error, trying to devise the best quality cuts for our 14 million objects, we ended up with a clean sample of that still contains 1,300,000 and more objects, which again are mostly not white dwarfs. But our aim here was to make sure that we were not excluding anything which is potentially a white dwarf. But this leaves us with the task of identifying which one of these objects are actually white dwarf in this clean sample. To do this, we decided to go back to a method completely analogous to what we did in data release 2, and that is to go back to our sample of spectroscopically identified objects from the Sloan Digital Sky Survey, but this time, not just the white dwarfs, which again I'm plotting in blue here on the left, but also the contaminants, which are mostly subdwarfs and main sequence stars, which I'm plotting in red. Using these objects in the HR diagram allows us to compute a probability map, which then allows to compute a parameter, which we call a probability of being a white dwarf, for any object which can be placed in the same HR space. The result is shown on the right, These are all of the 1,300,000 objects I mentioned before, but now their color reflects their probability of being a white dwarf, and you can see this gradient. Using this PWD value, a user then can apply a dynamic cat to our catalog, and so select subsamples of white dwarf candidates according to the specific tasks you want to achieve. To give you some reference, a cat done to all objects with a PWD value greater than 0.7 recovers 360,000 white dwarf candidates, a sample which we estimate to be between 67 and 93% complete for objects brighter than 20th magnitude. If we just compare to objects with spectroscopic information from Sloan, this sample actually includes 89% of all of the SDSS white dwarfs. And if we just look at the bright ones, brighter than 20th magnitude, the number jumps to 96%. This sample, however, still contains some degree of contamination in terms of spectroscopically identified objects from Sloan. There are 244 non-white dwarfs in this, which is a tiny number compared to 360,000, but surprisingly, there are still some quasars in there. So what changed? What's the difference now that we have an eDR3 catalog of white dwarfs compared to data release 2? Well, mostly we have new objects which are fainter. This catalog simply is pushing the boundaries of Gaia a bit fainter. This is what eDR3 enables. On the right here, I have the distribution of white dwarfs from eDR3 in red and data release 2 in blue as a function of Gaia magnitude. The top plot is a simple distribution. The one below is a cumulative distribution. As you can see, a real difference between the two samples only really emerges for objects fainter than 19th magnitude and really peaks just after 20th magnitude. The reason behind this is best visualized with the plot I have here on the left. This is the limiting magnitude for Gaia white dwarfs as a function of sky position for data release 2 on the top and eDR3 at the bottom. And each bin here is about 10 square degrees. And at the time of data release 2, you could see that the scanning glow of Gaia really stood out as a pattern in the sky, with areas that received fewer observations having a shallower magnitude limit. The same pattern is still kind of visible in eDR3, but it's now much smoother. Everything is much more uniform. And right now, we can quite confidently say that eDR3 reaches a limiting magnitude of at least 20 virtually everywhere in the sky. And this results in us finding fainter white dwarfs everywhere. Some of you that are familiar maybe with eDR3 and the publications that were associated with eDR3 may know that once we complete this, this will not be the first sample of white dwarfs selected out of eDR3, because in the publication of a catalog of nearby stars, there was already a selection of a small sample of nearby white dwarfs selected using some machine learning algorithm. We compared our selection to theirs, and the difference between the two is shown in these two plots, where on the left, these are all of the objects that were selected in these publications, but were not identified as white dwarfs by us. In red is all of the objects they classified as white dwarfs. In green, just the one that later made it into the 100 parsec sample. On the right is exactly the opposite, objects which we identified as white dwarfs, but were not present in their catalog. If we look at this plot closely, there's a lot of information we could extract, but there's just one thing I would like to point out in this talk, and it's that all of the objects in both samples are down here at the cool end of the white dwarf distribution. And in both cases, there is some odd horizontal distribution, which doesn't quite line up with the white dwarf's cooling tracks. So the moral of the story here is that even in 100 parsec, even in eDR3, the faintest, coolest white dwarfs are still challenging. And if these represent the core of your work, then users should be extremely careful with their selection of these objects. To conclude, I'd like to say that this is still work in progress, but the catalog should be available very soon for everyone. And there are a lot of additional elements to this catalog, which I do not have the time to explain here, but I'll leave them here as a list just to pique your interest. So stay tuned, and thank you for listening.
Great. Thank you very much for your talk, and thanks for ending very nicely on time. Okay. So I'm going to unmute you, ask you to unmute when you have a question, and And I think you have to unmute on your side as well. So let's start with Roseanne.
Oh, hi, everybody. That was a great talk. I do want to ask you about the issue of what about various types of white dwarfs that are either in binaries or interacting. It seemed like some of them, or maybe many of them, would escape the stringent limits that you put there. So can you tell us a little bit about that, please?
Yes, that's a good question. I need to point out that the catalog is tailored and optimized for single white dwarfs, or white dwarfs plus another white dwarf binary. Anything involving a white dwarf and a main sequence star, some of them will feature in the catalog, but the catalog is in no way complete. And for these objects, they are spread over a much larger color range, and it's really, really hard to construct a catalog that is also complete for these objects. So yes, my every statistics I mentioned, everything I said only applies to single white dwarfs, and binaries are challenging. In particular, the corrected BPRP excess factor, as it turns out, any cut that you do on that parameter, which is really important for faint objects, actually seems to exclude white dwarfs plus main sequence binaries. So something with an SCD that is very blue and very red at the same time with not much in the middle.
I think, do you have plans to take this in the direction of capturing the binaries, or is this the thing that you're most interested in right now?
There are plans, but the approach will be very different from this.
Thank you.
All right, let's go to Evan. Evan, I think I muted you on accident.
Oh, there we go. Okay, yeah. Thanks for a really clear talk, Nicola. I was curious about your selection based on crowding, and if there's any chance that could bias us a little bit in terms of things we might try to infer about different populations, completeness and the thin disk versus the thick disk or the halo or things like that.
Yeah, absolutely. So again, when I measure my completeness, here I did not have time, it's for higher galactic latitudes. The problem there is that if you devise a series of cuts, which results in a very complete sample outside of the plane or in non-crowded areas, if you apply exactly the same cut in crowded areas, you get a completely different result. So the same, so Gaia is not aware, in a sense, that it's doing worse in crowded areas. So the sample becomes much more mangled, particularly for faint objects. Yes, I worry that this could bias you if you are considering foreground of the Magellanic Clouds, foreground of the galactic plane, or even further into the galactic plane, together with low density areas. Yes, the selection is non-uniform, but I don't think there is right now a way around because Gaia underperforms in crowded areas. The photometry particularly is really, really bad there.
Any other questions out there? Okay, I'll ask a question.
Cool.
So I don't know the colors and magnitudes off the top of my head. Are you also picking up very young elms, very young, extremely low mass white dwarfs?
Again, I don't know. So elms occupy an odd space in the HR diagram. So I have made a quick comparison with non-elms, and the catalog does not seem to exclude them in any ways, but I cannot state if I'm complete, particularly if some of these are in binaries.
Okay, thanks. And we have a question from Stella. Stella, you have to unmute on your end too.
Right, okay, thank you. Very nice talk, Nicola. One question, is it going to be more realistic to find strongly magnetic white dwarfs? Can you say anything about that?
I don't want to step in anyone's territory on other talks. Strongly, so I don't think anything that eDR3 did is gonna make us more likely to identify strongly magnetic white dwarfs. I think that even in data release 2, those that had reliable data, there was nothing about them that made them more harder to identify. There will be more. That is for sure, because the completeness has improved across the board in for all subclasses in a sense. But considering where I've seen a highly magnetic white dwarf sitting in the HR diagram, there is not a region where much improvement has been made. It was already a relatively low level contamination area for white dwarfs at least.
Thank you.
And one more question from Roberto. Roberto, you have to unmute. There you go.
Hi, everyone. Nicola, I have just a very simple question. Would the use of the G versus G minus RP HR diagram help to select the targets and be less biased by the problem with the BP magnitude?
I can actually go back. So for example, one of the can you all see I went back a slide, right? So the other team that developed this Gaia catalog on unbiased white dwarfs selection didn't use BP minus RP, used G minus RP to avoid those problems, and it doesn't seem to improve things at the red end of stuff. And actually, if I do not use the BPRP corrected excess factor thing, I have no other way of excluding some objects which then seem to have reliable reliable astrometry, but completely bogus photometry. So I tested it. It impacts the catalog relatively. There's a relatively small impact in exchanging G minus RP for BP minus RP, but it makes me weaker when using the BPRP excess factor to exclude things, and that turned out to be something very important for the selection, particularly in crowded areas.
Okay, thank you.
Thanks. And unfortunately, Tom, we got to move on, but if you can have the discussion in Slack, maybe.
That works.
All right. So thank you very much for your talk, Nicola.